Recording in progress.
All right, guys, let's go to the homework. So this homework was actually pretty short. Hopefully you guys got done on Friday or sometime over the week or Thursday, whenever you did it. So the first problem is all about just review of old stuff. And you don't want to forget how to do this. I think that we did this in the first semester, so this probably won't be on the final exam because specific to the first semester, but still just stuff to remember and be good at. So solution key is right here. For 768a, x equals -4. For B, you're gonna have to do quad forms 5 plus minus 357 over 4. C is no solution. And the reason why C is no solution, it's hard to tell because it's really small, but if you see the fractions on each side, they're actually the same. 3 over x plus 2 plus 5 equals 3 over x plus 2. 3 over x plus 2 is actually cancel, leaving 5 equals 0. That's not a true statement. 5 cannot equal 0. Therefore, you get no solution. A is pretty simple. I guess you got the slip. Great. Just cross multiply and solve. That's pretty straightforward. But B is going to be a little bit more challenging. B, what I do is I find the LCD for everything, which is x times x plus 1. So you got to multiply both sides by x times x plus 1. Ellie, stop talking. Thanks. So what happens, you get 2x squared plus 2x on the right side. On the left side, multiply each fraction by, you get 3x plus 4x plus 4. Bring everything over to one side. That's going to make things a little bit dicey because it's not factorable, unfortunately. So you have to use quad form. Do quad form, you have 5 plus or minus root 25 minus 4 times 2 times -4 all over 2a. You should get root 57 inside the radical, and 5 plus or minus root 57 over 4. So that's that. For 769, some of you guys might have been a little confused by that question. It helps actually if you think of this three-dimensionally. So I do these dashed segments like this. And you have a segment inside like that. So that's the longest like pole you can put inside that box, right? What you're going to want to do is first draw a right triangle, kind of like the, kind of messing this up. Let me erase this again. Let's see here. Sorry about that. Here we go. Much better. Okay. So you got a right triangle here. Let me draw some green. So right triangle, that's like this. So it's 5, 4, and this face diagonal, because it's a diagonal of the bottom face. If you do Pythagorean theorem, you should get root 41. So that's going to be what you see in green. Now, what we'll do in blue is this. And that's another right triangle. Now, the hypotenuse of the previous triangle now becomes the leg of the blue triangle, which is root 41. And that's going to be 3. Pythag again, you get root 50. Root 50 is 5 root 2. So feel good? No, because we never really. This is just to make sure you guys are comfortable with Pythagorean theorem. This song is probably on the SAT if you do that next year. Yeah, but no, because this is not really what we're doing more trig, right? But you should know your right triangle stuff. For next one, area. That's just formulas you guys should know. That's 2 pi. Sorry, wow, I can't believe I said that. Pi r squared, and that's 2 pi r. Now this is a weird question. How many radii would wrap around? So basically, how many times you have to multiply the radius to wrap around the circle? It's just 2 pi times that radius. That's it. That's all it ever is. So it's 2 pi times the radius. Actually, they don't have the answer, which is kind of weird. I don't know why. Part B is actually part C, so it's kind of messed up a little bit. Does the size of the circle matter? No, because it's all proportional, right? So it does not matter at all. The circumference will always be 2 pi r. And then 360 degrees is 2 pi radians. We talked about that already. And 90 is a quarter. So it's 2 pi over 4 or pi over 2. Don't worry about 774. But as we know, a radian is the measure of an angle when the arc length equals a radius. That's how you can make sense of it. And then finally for 775, what I would do for this one, I think the diagrams are all here. But I'll just kind of do it from scratch. I would just draw one circle, actually. That'd be much easier. Come on. Yeah, one circle is much, much easier, I feel. And just label appropriately. All right, let's go red. So A would probably be like right here. Now that's about 57 degrees. We talked about this already. That's probably over here somewhere. Pi is over here, that's 180. Pi over 2 is 90, so over here. Pi over 4 is 45, so it's a little bit lower than B, so that's E. Halfway between A and D, or 0 and D. pi over 3 is 60 degrees, probably over here. And then G would probably be over here. That's how I do that. And that's it. That's the homework. Pretty simple, right? Okay. It's a big deal. We're doing unit circle, so get out 7, 6. This is absolutely a very big deal that we're doing today. So, because you have to know how this works in order to make sense of trig. Now, I don't think we do that much more trig after this unit, but pre-calculus, when you guys start pre-calculus in the fall, that's pretty much dominated by trig, like about 3 months. So you really want to have a firm understanding of the unit circle. Now, let me show you how the unit circle looks when it's filled out in all its glory. Let's see. I don't know why my computer's slowing down. That's really strange. Let me close some windows down. I don't need all this open. If I do a reboot a little later. Okay, here we go. Oh boy, I don't know why it's slowing down like this. Okay, here we go. This is called the unit circle. We talked about the unit circle already. We kind of know what's going on with the screamer, right? Okay. It looks a little daunting. Yes, I know. It does look a little daunting at first. Let me kind of explain what's happening here. So we know the center is 0, 0, right? Yeah, all circles have center, 0, 0. The radius is 1, right? This one, you just define it that way. So clearly this has to be 1, 0, because that's 1 away from the center. Likewise, it's -1, 0, 0, 1, and 0, negative. But don't just wait. Just don't put it. Just wait. Now we start here. So it's screamer right. Start here, and we go counterclockwise in positive direction. Positive direction is considered counterclockwise. So you go 30, 45, 60, 90, and so until you do 360. Now we talked about how to get these coordinates. We did talk about that. Like use like the 36-90 ratios. That's 1. You can figure it all out, right? Like was 45, 45, 90 or 60, 30, 95. Where it gets a little weird is like all the other ones, like, wait, what's going on? Why are some of these negative? Why are some of the positives? Also, how to figure out the radians, like, oh, why is it 5 pi over 6, 3 pi over 4? Do I need to memorize that? So initially, it looks like it's a big memorization thing. It's not. It's actually more of an understanding thing. If you understand how it works, you can actually fill this out pretty quickly without any notes. I'm going to show you how today. And why do you need to know this? Because in order to understand trig, you have to be able to recite. Not recite, it's the wrong word to use. You have to be able to evaluate, that's a better word, trig functions at various angles, like 120 or 240. Sometimes we go backwards. Sometimes we go around once, and then we go further. Like we do 2 rotations or 1/2 rotation. Like say I want to sine of 390 degrees. I go 360 and another 30 degrees. So we have to be able to do this quickly as you do more advanced trig down the road. Why do you need to do advanced trig? You definitely need it for physics. Well, a lot of you guys will be taking physics soon. Definitely need it for calculus. So these are all classes that you'll have to take down the road. We're just building your foundation. That's what we're doing. So that's kind of the whole point of this. So that, you know, I'm making sense of trig and other stuff is not that hard. All right, so let's just talk about the basics first. Sine and cosine, we know this, right? Sine is opposite of hypotenuse, cosine is adjacent from hypotenuse, so we know this, right? Tangent, TOA. And remember, this was just the y coordinate, and that was just the x coordinate. We know this, right? So this right here is cosine theta, and that's sine theta. And this right here is a length of 1. This is x, this is y, and that's theta. We know all those things. And again, the ordered pair, we know from our rectangular plan, which is x, y, can be labeled as, I already did it for you guys. It's right here. I don't need to write it again. It's the same thing, right? Same thing. What about tangent? Tangent is y over x, or sine over cosine, just so you know. Because you're doing opposite over adjacent, right? Y over x, which is sine over cosine. So once you know the coordinates at a particular point in the unit circle, the ratio of y over x is the tangent of that angle as well. Question so far? This is the foundation of the unit circle, right? Again, 0, 0 is where it starts. Radius is 1. The horizontal leg is x. The vertical leg is y. That should be intuitive. Again, the hypotenuse is 1 because that's a radius. Sine is y over 1, which is opposite hypotenuse, or y. Cosine adjacent to hypotenuse, which is x over 1, or x. Tangent opposite or adjacent, y over x. Sorry, I have cosine. We're good. So all's okay? All right, let's keep moving. Now, building a unit circle. How do you want to build it? Well, label x, y axes. So duh, that's x, that's y. Label the radian measures on the axes. Okay, so that's going to be 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and back to 2 pi. Remember, it's 0 to 90 to 180 to 270 to 360. So if you did degrees in blue, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So this is the unit circle. Okay, questions? No? All right. So recall from the last class, 180 is pi. So let's break up the fourths just so you guys are comfortable with that. So again, this is I'll do it in so we'll do degrees in blue. Okay, so degrees will be in blue. Radians will be in red. So here's where we start. We start here. And this is the, actually, let me change the colors of that. We start here. This is the positive direction. That's a positive direction. Counterclockwise, CCW short for counterclockwise. All right, so blue. Let's do all the degrees. That's 0 degrees. That's 90 degrees. I know it's kind of a broken record, but we really kind of have to do this so you really get how this works. And of course, 360 degrees when you go around once. Okay, now, that's all about proportional reason, guys. All proportional reason. That's all it's ever. So do not think this is memorization, please. I know you want to, but it's not. Everything in blue so far makes sense, right? Like 0, 90, 180, right? Just pressing into it. Okay, what's going to be half between 0 and 90? What's half between 90 and 180? Half between 180 and 270. 225, half between 270 and 360. Close. 315. So we write it. 45. 135. 225. 315 degrees. Okay. Now let's do in radians. Okay, that's 0 radians. Pi over 2 radians. Pi radians. Can't do a 3. Here we go. 3 pi over 2 radians. Okay. And back to 2 pi. Okay. What's half between 0 and pi over 2? Or what's half between 0 and half? Half between 0 and half.
0.25.
What's half of half? 1/4. Thank you. Oh, sorry. Yes. But sorry. Yes, you're right, Ellie, too. But we'll leave as a fraction. Pi over 4. Okay. So we're okay with that? That's pi over 4. Also, just think about it this way, too. 45 is what fraction of 180? 45 is 1/4 of 180, right? Yeah. 135. What do you multiply to 45 to get to 135? What would you multiply to this blue number to get this blue? Very good. So this should be 3 pi over 4. That should be 3 pi over 4. Okay. Now back here again. So 225. What do you multiply to 45 to get to 225? It's a multiple, right? 5. Thank you. 5 pi over 4. It can't be 4 because that would be 180, right? So it's got to be a little higher. Gus, go ahead.
What did it say about 45 degrees?
Pi over 4. Okay, 315. What would you multiply to 45 to get 315? 7, good. Because 6 would be right here. And 270, so it's got to be 7. And if not, 8 pi over 4 gets back to 2 pi. So you do not have to do the conversion. Please don't waste your time doing that. Some students feel like, oh, I got multiplied by 180 over pi or pi over 180 or whatever. No, Don't need to do that. It's all proportional reasoning. Yes, the radians is a little weird. You guys are getting still used to it, but this makes you more comfortable if you think about proportions. All right, let's keep moving. So this problem here, 3 pi over 2. Because remember, because that's 90 times 3 is 270. Here, I'll go back. Hold on. Here we go. What else do you need, Hunter? What else you need?
I don't know what that's like.
7 pi over 4. Because remember, we talked about 45 times 7 gets you 7 pi over 4.
And then what's that last one? 2 pi.
0 and 2 pi. Right. Let's keep moving. Okay, remember the unit circle is centered at the origin. X and Y values are positive and negative. So in this case here, if I say this is pi over 4, then that's going to be root 2 over 2, comma root 2 over 2. So this means that the sine of pi over 4 equals root 2 over 2. The cosine of pi over 4 also equals root 2 over 2. And the tangent of pi over 4 is y over x. Or what happens when you divide two things that are identical? What do you get? 1, exactly. Exactly, right. So you definitely need to know your 45-45-90 ratio. Remember, these are identical, they're opposite identical angles. That's 1. And the ratio is supposed to be technically x root 2. So if 1 equals x root 2, then x is 1 root 2. These, rationalize that. Especially for cosine. What's it's cosine 1 over 4? Pi over 4. Yeah, well, they're all pi over 4s. My pi just sucks. I have incredibly bad handwriting, so my apologies. Those are all pi's. Here, I'll do it again. Here, I'll just make it a little more. Does that make sense? Yeah. Let's make it a little more curved. I'm doing things in radians, not degrees, because I want you guys to get used to radians. It's kind of like another language. It's kind of like you have to immerse yourself in it to understand the language. So just gotta jump right in and just start doing the things in radians. Okay. Let's move on. We'll cut this into thirds now. Okay, let's cut this into thirds. So again, I'll just do things in well, let's do degrees first. That's my because I think it'll help you guys. 0 degrees, 60 degrees, 120 degrees, 180 degrees, 240 degrees, 300 degrees, 360 degrees. Okay, so in red, this will be 0 radians. Now, 180 was pi. We know this, right? 60 is what fraction of 180? Third, so you can put pi over 3. 120, what do you multiply 60 to get to 120? 2 pi over 3. Good. 240, what do you multiply 60 to get to 240? What do you multiply 60 to get to 300? 5. And then you get back to 2 pi. So again, it's all proportional reasoning. As long as you know this, we explain why this works. Remember, we did the radian, we figured out the arc length equals the radius. We did set proportion, 360 or 2 pi. R equals 1 radian over R. We did some possible kind of all worked out. It was good. So 60 pi over 3, 122 pi over 3 pi, 4 pi over 3 pi, 5 over 2 pi. Again, that's 1/3. That's double this. That's 4 times this. That's 5 times this. So it's just proportional reasoning. That's all you're doing. And if you need to watch the video, watch it again. If it still doesn't make sense or you still kind of want to resort to memorization, watch a video. So I'm making this video for you guys. All right, here we go. This is 60 degrees, or I'm going to call this pi over 3. Okay, that's 1. And that's going to be half and root 3 over 2. Right? Because that's a 36/90 ratio. So the sine of pi over 3, the cosine of pi over 3, and the tangent of pi over 3. Well, the sine is just root 3 over 2. The cosine is just 1/2. The tangent is just going to be root 3. Right? Sine is the y coordinate, cosine is the x coordinate, and it is 5 rows. Which is root 3. Questions? No? Okay, well, I think we're gonna do a 6 after this, like 30-degree angles. And again, yes, you do need to know your 36/90 ratios. Yes, you do need to know your 45/45/90 ratios, but the 45/45/90 is not that hard because you know that the two legs are the same. Use some diagrams and get everything else. Here, this is like actually happening a lot of times, right? Because two people have triangles. You know, if you make this 1 and 1, and this whole thing is 1, so that's all it comes from. Not that hard. Let's keep moving. Yeah, what's up? Root 3 over 2. Because I'm doing y over x, right? My y is root 3 over 2, my x is 1/2. So I know my 3's suck. I apologize. I still need to get a stylus. I've been lazy about it. Here you go. And you just divide the fractions, right? 2's cancel. All right, let's keep moving. Okay, let's cut this into 6 now. So let's do blue in degrees again. 0 degrees, 30 degrees, 60 degrees, 90 degrees. I think you guys get the idea. 120, 150, 180, 210, 240, 270, 300, 330, and 360. So in radians, it's going to be this. 0, that's pi. Okay, so again, let's use proportional reasoning. 30 is what fraction of 180? 1/6, think about 1/6. So that's going to be pi over 6. That's 2 pi over 6, which is just pi over 3, right? We know this is pi over 2, or 3 pi over 6. We know this is 2 pi over 3, we just did that one. What do you multiply 30 to get the 150? What do you multiply 30 to get 150, guys? What do you multiply by 30 to get the 150? Does that make sense, Hunter? 5 times 30 is 150?
Oh, I just didn't get a question. I was right.
Yeah, no worries, it's okay. So 5 pi over 6? Oh, geez. Then what do you multiply to 30 to get the 210? 30 times what gets us 210? Or 210 divided by 30? So good. Yep. 7 pi over 6. This will be 4 pi over 3 or 8 pi over 6. You want to think of it that way. We know that's 3 pi over 2. 5 pi over 3. 11 pi over 6. And finally 2 pi. And again, 330 is 11 times 30, right? So, yeah. Okay, A-okay?
I'm still ready.
Take your time. You're good. Let me plug my laptop. Okay. So can I move the screen? Oh, wait. All right. So we work this out. Not that bad. That's 1. That's pi over 6. So if I do, and the coordinates here are √3/2, comma 1/2. So sine of pi over 6, cosine of pi over 6, tangent of pi over 6. Sine is the y coordinate, 1/2. Cosine is the x coordinate, √3/2. And tangent is y over x. Which, by the way, will be 1 over √3. Or, if you rationalize the denominator, √3/3. Okay, finally, I do 3's more nicely this time.
A little bit of glare, my apologies. You do a fraction over fraction. Remember, we like fraction, I'll put the bottom fraction, cross that too. I will say this though, this is very fraction heavy. So you really have to be very comfortable with fractions. And in your defense, 4 years ago during the pandemic, you guys were in 6th grade. A fraction is supposed to be taught really well, and probably wasn't. So if you have a tough time with fractions, talk to me. I could help you guys out. I get if the fractions are a little shaky because of COVID, but this is very fraction heavy. We can't really avoid that, unfortunately. So let me know if you're having a hard time with fractions. We can work through it. But fraction division, remember, you flip this fraction you're dividing by, and then multiply afterwards, right? So, all right. So now we're ready to fill this out in all its glory. Okay. And then we'll answer some questions, and then you have homework at the end. Okay, so the homework's included here as well. All right. It's debating if I should do this on Zoom or if I should do this on the board, but let's see if I can let's see if I can do this here. 1 0 0 1 -1 0 and 0 -1. We're okay with that so far? That's okay, right? Okay. Blue will be degrees. So (0 degrees or 360 degrees, 90 degrees, 180 degrees, or 270 degrees. This is going to be real interesting because I'm kind of struggling with doing this in a finer way. Okay, that's okay so far, right? 0, 90, 180, 270, 360. All right. Okay with that?
Good. Okay. Now let's do all the ones in each quadrant. We're going to call this quadrant 1. We're going to call this quadrant 2. We're going to call this quadrant 3. We're going to call this quadrant 4. Why it was divided this way, I don't know. But quadrant 1 always starts in the upper right and it goes counterclockwise. And remember, that's a positive direction. Counterclockwise, okay? Counterclockwise, positive direction. So remember, this is 30. This is 45. And that's 60.
$30, 45, 60. Okay. These are the standard angles. These are the standard ones. Then you just have to just use symmetry afterwards. What was this? This one maybe that's 60, that's Exactly, because they're have to be equal distance away from y-axis or the x-axis.
So 120, 135, and 150. Why don't you guys try filling out the rest, the bottom half, for just degrees, just degrees. I'll freeze my screen for a moment. And the one thing that I want to inform you guys about, we actually deliberated often. We actually kind of wrote the test, so we kind of have an idea of what the test is going to look like. It could change. Most likely, we're going to
Test probably Friday for that. Testing Wednesday a little too soon. So we went back and forth. Initially, we wanted to not give you a filled out historical for a test, make you guys fill it out. I thought giving a filled out one was a little too easy. So what we're going to do is we're going to give you a partially filled out. Partially, so we've got a compromise. We give partially. So on the test, which we'll have until Friday, we're about to break April 12th, I'm guessing. We'll give you a partially filled out one. So that way you can kind of use some symmetry, right? To kind of make sense of it. So like maybe something to fill in the first quadrant, some the second, some the third, some the fourth.
and have you guys fill out the rest. So, because I think you guys are still learning, because you're going to see us again next year for sure. All right, let's keep moving. So it should look like this, right? Okay, now let's do all the radians in red. So remember, this was 0 radians, and that was 2 pi. That was pi radians. That was pi over 2 radians. That was 3 pi over 2 radians. Okay, we know this. Remember, 30 was 1/6 of 180. 45 was a fourth of 180. 60 is a third of 180. 120 is double 60. 135 is triple 45. 150 is quintuple if you want to use that for 5 times 30. So notice how I'm not memorizing at all. I'm actually terrible at memorization.
I guess probably my worst class, two of my worst classes in high school were geometry, because I cannot memorize the darn theorems, and biology, because I just don't hate memorization. I just can't stand it. I'm not memorizing, I understand. I know 30 is 1/6. That's 5 or 6. I know 1 5 times 5, 5 or 6. I know that, right?
So I'm using just logic. That's all. So if I keep going, 210 is 7 times 30, 7 pi over 6. 225 is 5 times 45, so 5 pi over 4. 240 is 4 times 60, 4 pi over 3. 300 is 5 times 60, 5 pi over 3. 315 is 7 times 45, 7 pi over 4. 330 is 11 times 30, 11 pi over 6. Okay, so we're starting to get more of this now complete. Okay, the last bit are the coordinates, which I'm going to 7 pi over 4. You're doing 7 times 45. Yeah, I know. It's hard to squeeze it all in. Okay, so the coordinates here. Oh, boy. Okay, let's just do it. Root 3 over 2 and 1/2. Root 2 over 2. Root 2 over 2. And then it's reversed here. 1/2 and root 3 over 2.
We already did this, right? Because remember, that's 1. That's gonna be root 3 times. Sorry, that's gonna be the vertical leg half of that hypothesis 1/2. And the horizontal leg is root 3 times this, so that's root 3 over 2. That's 30 degrees, that's 60 here. And that's these are identical root 3 to root 2, and that's the reverse of this. Now here's the deal. All the other ones are the same thing, right? What's the only difference between Q2 and Q1? The only difference between Q2 and Q1 is what? Negative for what? X or Y. Thanks, we have steps. That's all it is.
That's all it is. Just make this negative half root 3 over 2. Make this negative root 2 over 2, root 2 over 2. Make this negative root 3 over 2, 1/2. There's a negative there, sorry. Now in the third quadrant, X and Y are both what? Both, yeah. So here X and Y are both positive. Here, X is positive, but Y is negative. Here, X and Y are both negative. And here, X is positive, Y is negative. So, yeah, they're all negative here. And that's it. That's the unit circle. So sometimes we do this also. All positive, sine positive, tangent positive, cosine positive.
All trig functions are positive first quadrant. Sine is one positive second quadrant because y is positive. Now x are both negative, but we divide the negative by negative. Tangents that also replace the positive tangent. Cosine positive the fourth quadrant is x positive. There's a mnemonic. All students take chemistry, or all students take calculus. You have to remember.
But as long as you know the coordinates, like x is cosine, y is sine, it's not that hard. So all sine, tan, cosine. Sometimes I like to do this. It's kind of a little fun thing to do. Okay, well, it's taking. We're usually I like to kind of have this on a blank white background, but yeah, it just kind of looks cool. I don't know. Anyway, maybe it's not. Don't care. Okay. Really slow. I don't know what's going on here. Okay. So now, how do we use this? Okay, how do we use this? So we use this by evaluating all these different trig functions. Okay. So cosine 3 pi over 2, sine, sine, cosine, cosine, so forth. So let's do. So here's what you do. It says draw a circle, label angle, find a trig expression, blah, blah, blah. You know, so I just do this seriously. I just say, hey, this is X, this is Y, this is Y, this is X, this is Y, and this is X. Okay, actually, we should draw a circle. That's actually more to think about now. We should. Okay, 3 pi over 2. Okay. Tell me when I've rotated 3 pi over 2. Or tell me when I'm at 3 pi over 2. Tell me when to stop.
Stop.
Thank you. So really what you have to do is this. I kind of don't like these instructions. Really, it's a two-step process. Figure out which coordinate you need. And location. On unit circle. Okay, location on unit circle. So, which coordinate are we going to use again for this one? X, right? So the answer is 0. That's all. Just 0. Yeah. You got to do this without a calculator. You got to do this without a calculator. Yeah. So, I mean, you can check your work using a calculator, but you got to be able to do this without a calculator. So, this all has to be done. This is all non-calc, guys. Cannot use a calculator here. Yeah. Okay. Okay. Sorry. Yep. I'm going to be very strict about that. Okay. Negative means going clockwise. Okay. So 5 pi over 6 was over here, right? Remember 5 pi over 6 is over here? It was 150. So we're going the other direction now. So that's going to be negative 150. So tell me when I've traveled negative 150. Let's go red again. When have I traveled negative 150? Tell me when to stop. Good. So that will be very similar to 210. Those coordinates are negative root 3 root 2, common negative half. Use your unit circle, by the way. But you want the y coordinate, so it's negative 1/2. Okay, I'm going to go a little faster now. 7 pi over 6. Tell me when to stop. Okay, good. Let's just stop here. It's the same coordinates as before. Y coordinate again. Negative half. 5 pi over 4. Once you get very good, you could just kind of go straight to it. Eight pi. I'll do the coordinates just a sec for all these remaining parts. Okay, 8 pi is actually 4 revolutions. So you go once, twice, 3 times, 4 times. You end right here. So 1, 0. Cosine 5 pi over 3. So that's 1/2. That's 0. That's negative root 2 over 2.
Okay, so you gotta know which coordinate you want and the location on the surface, depending on what the angle is.
And again, know your unit circle so that way you don't have to convert these to degrees. Once you know the unit circle, it's pretty easy. And you got it. So once you have it filled out, it's not hard. Filling out could be a little bit of challenge to that, but we talk about filled out, it's all proportional reasoning. You have filled out right now, so it should make the homework not so bad. Last thing we're going to talk about is reference angles. So reference angle is basically an acute angle that's in the first quadrant that you use as a reference to other angles. Like 129, the reference angle is 51 because it's 51 degrees away from the x-axis, or 231 also as a reference at 51 because it's 51 degrees away from the x-axis, or 309 is 51 degrees away from the x-axis. And then you have a bunch of other stuff here to work on. So that's all. I'll actually work this out and have the answer key ready. I'll do while you guys are doing it. Or if you want a little break, because we got 12 more minutes, so and we'll break a little early for lunch too. So, yep, I think we're all set.